In this video, we're going to do 8.04 box spin. So I already have it downloaded and opened up in DrRacket. So let's just get started. So it says design a world program that grows a rotating red square that is always centered like the following image, right? So you can copy and paste this URL and then paste it in your browser like so, right? So it's going to look something like this, right? It's going to have a square starting very small, right? Maybe non-existent. And then it's just going to keep growing and rotating at the same time. In fact, let me just show this what it looks like right here. All right, so you guys can get a better idea of what you're making. All right, so there we go. All right, it's just going to rotate and grow at the same time, always staying centered. All right, so let's just go back to our problem here. Call your data box, and note that this can be done without compound data, but please use a compound data definition. Follow the htdw recipe. All right, so you can always find it over here, right? Going to this templates page and then going here and then pasting it in your browser. So I'm going to go here and paste it in like so. And it's going to be right over here, Big Bang World Apps. All right, so start off with sketching it out, identifying all the constants, the Big Bang options, and the changing information, and etc. All right. So pause the video and try to do this problem on your own. I am going to go over spoilers in 3, 2, and 1. All right, hopefully you guys gave it a good swing. So let's just go with our domain analysis. Hopefully you guys did something like this to break down the problem. So the constants are the width, the height, right? The width and height of the canvas. The background also stays the same. The rotation speed, right? How fast it rotates. Growth speed, how fast it grows. Center X and center Y, because they're always going to be centered. Sorry if it doesn't look that way if you had the drawings, all right? So that's all the constants done. Let's start transcribing them in a second. The changing information next is the angle and the side lengths, right? So the angle is always going to be rotating, right? It's going to be increasing, and same with the side lengths to make it grow. Big Bang options are going to be onTick and toDraw, because we need onTick to grow it and rotate it over time, and toDraw has to draw the images, right? So let's start by transcribing the constants over here. So define width, we're going to say 400. You can pick different numbers for the canvas size, all right? And that's fine, right? No problem at all. I'll just note that it's a little harder for me to grade, world programs, because you guys can make, you guys can decide, I want my speed to be 10 or something, or I want my width and height to be 500. That's absolutely fine. Just make sure that your program looks like mine. And we have no problem, right? It's just hard to grade on the auto grader. So center Y is one of the constants. It's going to be height divided by 2. Right, next is the background. Let's do the background up here. I always like it to be near, the width and height, because it uses the width and height. So empty scene, width and height. All right, and then what else? So the rotation speed. So we'll say it's 4 for this problem. You guys make it any number you want. And then we'll say the growth speed is 4. All right, so that's all the constants transcribed. All right, so now let's move on to the data definitions. All right, so try to pause this video and then, try to work through this step. I'm gonna go over spoilers in 3, 2, and 1. All right, so assume that you guys gave it a good swing. So we have to call it box, right? Call your data box. And we need, something to store its side length and angle. So define struct box. Right, we have to keep track of the side length and the angle itself. All right, so it's going to be box is make box, and then the side is going to be a natural number, because there's no such thing as a geometric shape that has negative side lengths. An angle, it could be any number, honestly. Right, because negative just means it's going to turn the other direction, right? So next is the interpretation for each of these fields. So side means side length of a square. All right, and then angle is counterclockwise measured in degrees. All right, not radians. So there we go. That's as specific as we can get it. Right, so let me just check myself off for these steps. So that's the description done, interpretation step done. We should also write these signatures here. So we get some core DC functions. So box side consumes a box and produces a natural number. And similarly for the angle itself, like so. Right? It's going to produce a number instead. So by declaring 41, right, this gives us these two functions in the environment. All right, so let's come up with some examples here. So I always like to do, B0 to be a box of 0, the side length of 0 and a rotation of 0. Let's do another one. So B1 is going to be make box of 20 rotated by 45 degrees. And then we'll do another one, make box has a side length of 30 rotated by 90 degrees. All right, so there we go. Let me just check myself off. For example, let's move on to a template that processes data. So anything that processes a box most likely has to take apart its constituent pieces. So we're going to need the side of the given box and then do something with the angle of the given box. All right, so that is the template done, right? Outlining the data like so. All right, now let's move on to functions. So try to pause the video here and work through that step. All right, so I'm gonna go over spoilers in 3, 2, and 1. All right, so let's identify the Big Bang options over here. So we only need onTick and toDraw for problem A. So we don't need stop when, and we don't need onMouse because there's no mouse interaction with this problem. We will need onKey for problem B, so I'm gonna comment this out for now. All right, so now we just have to do the Tock and the render function. All right, so let's get started with the Tock function right here. So pause the video and try to work through the Tock function following these steps. I'm gonna go with spoilers in 3, 2, and 1. All right, I'm assuming that you guys gave it a good swing. So if you're stuck on this, maybe it would help to rename this function to what it does instead of like Tock, because it's rhyming with tick right here. So we're gonna call it, advance box, like so. All right. And instead of world state, we have to change all these signatures to, what it is, what it actually is now. Right. So this, it's going to be box for all the signatures right over here, like so. Main also. Right. And let's just change, WS, the parameter name, to BX. So hopefully that makes things a lot more easier to process. All right. So what is the purpose of the advanced box function? Well, it's going to produce the given box with increased angle, increased side length and angle. All right, increased side length and angle. All right, that sounds good enough, even though it's meh. But we can always come back to it. So that's the signature, that's the purpose. Let's do the stub for this. So advanced box is given a box and we have to produce a box, right? So we have to have something that produces a box like so. Let's just use the values 0, 0 for the stub. Next, let's just go through some examples. So check, expect advanced box of B0. So if you guys remember, B0 is a box with 0 and 0. So we have to advance the box, increasing the side length and the angle. So we have to produce a box in the end. I'm going to split this up into another line. All right. And let's see. If we're going to increase the box's side length by 4, so if you remember our constants earlier, like so, increase it by 4 and rotate it by 4 degrees. So it should be 4 and 4, like so, right? We should end up with a box of side length 4 and rotation 4. But let's just use the constants for these. So to make it more clear, we're adding to the x, not the x component, the side length, the growth speed, right? And then the angle, let's see, 0 degrees, and then the angle is going to be what? Rotate speed, like so. All right, let's do one more example here. This isn't really, a super complex function. All right, so let's say we're given a box of, let's say, make box, 40, 54, 21, right? So of course it's going to produce a box that increases by the growth speed. So 54 plus 4, so this is going to be 58, and 21 is going to be the angle plus whatever the rotation speed is, right? So that's what the Tock function, not the Tock function, the advanced box function is going to produce. All right, so let me just run this against stub, and it's just mismatches, all right? So it just differs. that's fine. All right, so now let's just grab the template. So let me check my steps off, like so. So you guys can see where I'm at. So signature, purpose, stub, we just did that, right? Signature, purpose, stub, examples. All right. So next is the template from data. So we could use the template because it consumes a box. And here's the template, the outline for a box. So the starter. So let's just do that. I'm going to comment out the stub for now. There we go. You guys can remove it if you like. And you got to rename this to advanced box. All right. So now we can code the body. All right. So now you can really pause the video. This should be all the mental scaffolding needed for the Tock function, the advanced box function, I mean. So pause the video and try to take a good swing at it. I'm going to assume that you guys took a good swing at it, right? Spoilers in 3, 2, and 1. All right. So we know that this function has to produce a box in the end, right? So we can use that to deduce that we do need make box. And we have to increase the side lengths by the growth speed. And likewise the same for the rotation speed. All right, the angle. We have to increase it by the rotation speed. Like so. All right, so now we run this, all the tests should pass. And so they do for the advanced box function bound to the onTick clause. All right, now let's move on to the render function. So pause the video and try to take a good swing at that. All right, so I'm assuming that you guys took a good swing at it. So let's see. So it has to take the box and produce the image of the box. All right, so that's a signature. So purpose, produce image of box, rotated and expanded onto the background. All right, so check. Well, not yet. We gotta finish the stub. So you can use empty image, right? That's an image over here. So now we can do the check expect. So render, let's say, we'll say something like, let me just scroll up here. B1, so that's, I'm just going to copy and paste this so I don't have to keep scrolling back up for the dimensions, right? So you guys could use B1 here, but to make this, more readable, right, from the get-go, I'm just going to use B1 for now. I would recommend you guys use the constants though, but to make it easier to see, I just want to do this. All right, so we're going to have to do a place image here. All right, we want to place this box, right? It's a box structure, right? It's not an image, so we have to turn this into an image. So we're going to have to do a square of the side length. So in this case, the side length is 20 for this box, and then rotated 45 degrees. So we're going to do that a little later, but this is going to be a solid red box. All right, and we're also going to rotate this. Rotate it. I forgot which one came first, the image or the degree of rotation. I'm going to say the image comes last, but I could be wrong about that. You could always right click and search in help desk, but I'm just going to wait until I run the stub and see if it yells at me. So that's the rotated box, and we have to place it in the center, X, center, Y. And then lastly, let's see, the background, right? We want to place this rotated box on top of the background at the center point. So we run this, we should see, what it looks like. And as you can see, rotate expects an angle in degrees as its first argument. So I was wrong, right? We need 45 to come first. Like so. All right, so now we should see the image. All right, so it looks something like that, right? What is it? 20 side length box rotated 45 degrees, looks like a little diamond over there. All right, so, this empty image differs from this box. That's fine. It's just the stub. Let's do one more example for good measure. So we'll say, 90 degrees, and, maybe it's increased to a side length of 40. All right, so the things that would need to change is we're going to be rotating it by 90 degrees now. And then the square is going to have side length of 40, like so. All right, so now we run that. We should see what that looks like, and it looks like that, right? 90 degrees rotated with a side length of 40. All right, so now let's just take the template and try to work on this. So that's the signature, purpose, stub, examples. So next to the template, so let's just take that. So right over here, and then we're going to code the body shortly. All right, so I'm going to comment out the stub, and there we go, paste in, and then rename this render. All right, so now really pause the video and working on your own, because this should be all the mental scaffolding needed to solve the problem. I'm going to go over spoilers in 3, 2, and 1. All right, so hopefully you guys gave it a good swing. So let's see, this has to produce an image, and it looks like our examples say that we're going to do a place image of all this stuff, right? But, you know, this is the main things where things change. So let's just do a place image. All right, and then we're going to need to take the side length. So this is where the side lengths go, and then this is where the angle goes, right? So we're going to need a rotate. So rotate, and then the square. All right, so this is where the angle goes. So we're going to take the given box's angle and stick it in that slot. And we also need the side length to go in this slot, so right after the square. So we're going to need the side like so. All right, that's the changing argument over here. That's 20, that's 40, that's 45, that's 90. And the box contains those numbers. All right, so square, and we also need solid red. So solid and red. There we go. And we want to place it on the center X and center Y, and always on the background. So BG, like so. So I'm press Control I to reindent, run it against the test, and they should pass. And so they do. All right. So if I scroll up over here, let's see, start rolled with, we're going to say main make box of 0, 0. All right. So let's just run this off to the side, and we should see our growing red box like so. All right. All right. All right, so now let's move on to problem B. Make it so pressing R resets the rotating square back to its initial state. All right, so pause the video and try to work on that. I'm gonna go with spoilers in 3, 2, and 1. All right, hopefully you guys gave it a good swing. So we're gonna need the on key function, because when we press R, we will need to handle that key. All right, so the name is gonna be handle key. So let's grab the handle key template from the website and start working on it. So there we go. Here's the template. Where is my handle key? Right over here. All right, so let's just paste it down here like so. And the world state is now, you know, box, and it should produce a box. All right, so that's the signature. Next is the purpose. So produce a box of 0 of side length, 0 angle, 0 when R key is pressed. I'm going to quote that R. There we go, just to make it a little more clear. Otherwise, you know, don't do anything if you press any other keys. All right, so that's the signature. Next is the stub. So we can stub this out by making this, you know, a box of 0. So I'm just going to copy this and make the stub right now. I'm going to comment that lower one out. All right. So, you know, this has to be make box of 0, 0. And we also have to produce a box for the else case, like so. All right. So there we go. Let's write some tests for this. So check, expect, handle, key. So let's say we'll give it a box of B1. Doesn't really matter what, we don't really need to care about, you know, the specific box dimensions here, because I'm not really going to use it, because you're going to see in a second. All right, so B1, and let's say the key that was pressed was, you know, the R key, like so. All right, what do we want to produce? Well, we want to produce and reset it to the 0 box. All right, likewise, let's do one more case for when we press an irrelevant key. Let's say A, right? A is just gonna produce, you know, B1. All right, B1 again is a, let's see, make box 20 of 45, right? 2045. So let me just scroll down here. And if I press A, don't care, just give me back, the same box I passed in. All right, so this is the template. So I'm going to delete. Well, first of all, I'm going to run the test against the stub. And just mismatches, that's fine. All right, so now, there we go. I'm going to delete the stub now because it's really no longer needed. And here's the template to work on. All right, so now I'll pause the video and try to work through the solution on your own. I'm going to go by spoilers in 3, 2, and 1. All right, so hopefully you guys gave it a good swing. So if the given key was the R key that was pressed, we do have to just reset it. And resetting it just means that, hey, we're going to make a box of 0 side length and an angle of 0. All right, otherwise, if I press, the A key, the shift key, the space key, we don't want to do anything to that box. So that's just going to be the given world state, right? The given box. In fact, I'm going to change it to BX, like so, just to reflect the naming here. All right, so we run it, all the tests should pass, and so they do. So now if I run this program with main make box 0, 0, all right, so we're going to see that our box grow, but when I hit the R key, it resets, right? And that is pretty much it for this problem. All right. Thank you for watching, human. If you wish to interact with more of your kind, join our Discord linked in the description or on screen. If you want to aid in my quest for world domination, consider hitting the sub button. Thumbs up if you enjoyed it, thumbs down if you didn't. Any questions, comments, or suggestions, fire away below. Also, check out the annotations on screen for the next relevant video.